Welcome back. This is the last and final video on the series of carbon, hydrogen, and element combinations. We've already looked at carbon, hydrogen, and halogens, and then we looked at carbon, hydrogen, and oxygen. Finally, carbon, hydrogen, and nitrogen. Why are we focusing on these three primarily? Is because a great deal of carbons have either an halogen or oxygen or nitrogen, and carbon and hydrogen are default. Okay, which is why we're focusing on these three first, and then work our way up slowly. Okay. So nitrogen can connect to an element through one triple bond or three single bonds. Okay. What I'm trying to say here is the nitrogen itself, that we know of, is made up of a triple bond. This is the structure of nitrogen itself. So nitrogen can connect to another element through one triple bond to another element or an element of its own kind. Either way, that's a triple bond, or it can connect to three elements through three single bonds. That's what I really mean by it can connect through one triple bond or three single bonds. And you all know what this is. This is NH3. Can be written this way. And again, you don't need to memorize this. Okay, this is just to inform you on what I'm trying to say. This is the ammonia that you get at Kroger to use with your cleaning of your clothes, right? So there's only two possibilities. Nitrogen can exist as three single bonds or one triple bond. We're going to see that in action. Okay. As with the previous case, the calculation is very straightforward. First, you do the original, which is CnH2n plus 2. And if you do that math, it'll be C5H12. So that's your original. And then for nitrogens, okay, for nitrogen, every nitrogen you take out one hydrogen. Every nitrogen you subtract one hydrogen. Okay. What that means is we have only one nitrogen, so we subtract one, so we get C5H8, right? So that's our given. We take our original, we put our given, and we get 4 out of 2 double bonds. That makes sense, right? 2 double bond is same as 1 triple bond, right? So how do we go about this? I'm going to show you, just like I did for the oxygen, 2 different ways of writing it. Okay, let's start with the purpose why we're doing this. So let's write 5 carbons. Okay, since we have 2 double bond, remember I said 1 double bond is equal to this, and 2 double bond is equal to this, right? Now you can do it 2 different ways. I'm going to show you the first method, which is you can add the nitrogen at the end, and if you do that, okay, then you can connect the nitrogen to the carbon through all 3 single bonds. And you see chemistry is so beautiful, right? Now when we do that, the carbon now has 4 bonds, it cannot take anymore, and the nitrogen has met its 1 triple bond requirement. So you can stop right here, okay? This probably will not happen inside. Now, special cases, carbon and nitrogen, this triple bond can only appear on the end. Okay, if you chose to use the double bond with the nitrogen being a triple bond, it can only appear on the end. It cannot go in between. What I'm saying here is you cannot, I know what you're thinking. Can I do this? Well, you can for 2 reasons. Why? I said you can. Even if you didn't know that, you know carbon cannot have 5 bonds. So this is not a possibility. This triple bond option can only appear on the end, either this side or the other side. It doesn't matter, but it can only happen on the inside. Once you want to say, but we know this molecule contains a double bond, but why do you want to explore other options? Well, you can do this. You can put the triple bond in the inside now. Then we've adjusted the double bond using the triple bond, but now your nitrogen cannot have be on the outside, but it can only be attached to, it's attached to 1 through the carbon. That means it has 2 more. If you do your math right, you'll be left with 3, 5, 7, right? We need 9 hydrogens, right? So 7, the 2 hydrogens go here. You see, now this looks like this, except this nitrogen now has 3 single bonds. In this case, if you fill, you will be left with, you know, again, it's important you keep track of your carbon count, carbon number of bond counts, nitrogen, number of nitrogen bond count, and hydrogen count, okay? You can also try this way. Say if you want to do the, like I said, the triple bond, once it's inside, nitrogen must have a single bond, right? So you can also have this way. The nitrogen can be here. Okay, in this case, the carbon has 3 bonds, so the 4th bond must be a hydrogen. The nitrogen has 1 bond, so you can have 2 more. The 2 bonds must be hydrogen. Now you can fill the rest with your hydrogens, which again leaves you with C5H9N. So if you choose to explore the nitrogen as a triple bond, it can only be on the end. If you rather would do a triple bond in the inside, then the nitrogen can be anywhere, but then the nitrogen can only have 3 single bonds. Okay, I've tried to make this concept simplified because this can be taught extensively only to confuse you, but I've kept it very simple so that this is the part that you need to know. Everything else is just fluff, and I don't want you to know that. Okay, so these will be 3 separate videos, one with the halogens, one with oxygen, one with the nitrogen. Start with one and understand it thoroughly. If you do, the rest is easy. And of course, I don't expect to comprehend all of this in one straight attempt watching a video. Sometimes you have to watch more than once. Of course, we practice a lot in class, so you will get it, but you have to believe you can understand it. All right? All right, I'll see you with nomenclature in the next video.